The future of this PKI is related with the PQC, post-quantum cryptography. Now move on to the next session, next part of this session. That is the title as given me from the organizer, that PKI and secure protocols. Because if we summarize the PKI, public key infrastructure, means you need a particular infrastructure, that one is secure in all sense, from the sender side to the receiver side. The transmission medium is so secure that the message should be encrypted and no one can alter during the transmission. We can use certificate authority, we can use others medium like digital certificates and other kind of solutions for secure transmission from one end to another end. So there is a particular need that we need to use secure protocols. Secure protocols, what does it means, the secure protocol? So secure protocol define standardized rules to protect data communication. Why we need secure protocol? Secure protocol gives us the confidentiality, integrity, authentication, CIA as the most important pillar of this network security. And another fourth one is non-repudiation. So CIA principle is the main objective to use the secure protocols. So you can use the CIAN, non-repudiation. So built using cryptographic primitives and PKI based identity management. Secure protocol are very essential for all of us. In protocol designing, actually I have worked in protocol designing since 2017. The core security principles in protocol design are four. First one is least privilege. Second one is defense in depth. Third one is perfect forward secrecy. And fourth one is replay resistance. Least privilege means only necessary access will be given to the users at what level they are. Defense in depth, layered encryption and authentication is going to perform on the layer basis. Perfect forward secrecy means session key independent of the long-term keys. And replay resistance, it's a very good initiative, and timestamps and nonsense prevent reuse of old sessions. So we need to understand this SSL, secure socket layer, and TLS, transport layer security. Actually, in 1995, Netscape developed this secure socket layer, SSL. And later on, this evolved as a transport layer security, TLS. So we are using SSL, TLS, both as a keyword, SSL, TLS. And nowadays, we are using TLS mostly. And this provides confidentiality and integrity between client and server. And it operates between application layer and transport layer. So TLS handshake mechanism steps are available in this screen. You can see in the first step, client hello. It means supported the cipher suits random nouns. Step 2, server hello. Chosen cipher suit certificates. Step 3, key exchange using RSA. Step 4 is session key generation. Authentication and MAC verification is the last step of the TLS handshake mechanism. TLS 1.3 improvements. TLS 1.3 is the improvement version of the TLS. Here in this particular improvements of TLS is it reduced handshake latency, removed obsolete algorithm, enforced perfect forward secrecy, early data support with replay protection mechanisms. So all these are the improvements of TLS 1.3. TLS cipher suits, it means the defining the encryption, key exchange, MAC algorithm used in this session. You can see the example of the TLS like this in the screen. And this is the breakdown of this example. The first part of this example is ECDHE means key exchange, then authentication, then encryption, and then last one is hash function. Or you can see like this. This is a MAC available in SHA-384 format. So one of the important case study related to this is available in your screen, that is available from the 2014, and it is discovered in OpenSSL TLS heartbeat extension. And attackers in this particular vulnerability, heartbleed vulnerability, is publicly available, where attackers could read up to 64 KB of server memory per request. Private keys and user data were exposed in this particular vulnerability. So the main lessons is we need to validate input buffer boundaries and perform continuous security auditing. Case study another regarding this, the Poodle attack in 2014. So the padding Oracle on downgraded legacy encryption. This is the Poodle padding Oracle on downgraded legacy encryption, and it is exploited SSL 3.0 fallback and CBC padding flow, and it is allowed decryption of secure cookies. And this was the attack happened in 2014. The main mitigation approach was the disabling SSL 3.0 and weak cipher suits and enforced TLS 1.2 or higher. So this was the mitigation approach after we use this attack, the Poodle attack. Now we are aware of the TLS 1.3 and SSH. So if you want to deploy this SSH in real racks, so you need to understand the remote login and telnet and the file transmission by using tunneling in secure medium. So uses public key authentication and encrypted channels are essential. So understanding about this architecture is that one uses transport layer, user authentication layer, a connection layer. So all this is required because SSH architecture consists all this. Password based, public key based, and host based supported authentication is available in SSH. So you can apply anyone for the authentication. SSH key management, you can use key generation mechanism SSH, any RSA, ECDSA, or any ED25519, and you can store your key, authorized key, in this particular repository like /.ssh/authorized keys. And mismanagement leads to lateral movement and enterprise attacks. So one of the important compromise or a particular attack that was happened in 2022 regarding GitHub SSH key compromise. This is well-known compromise that was happened with the GitHub. So GitHub rotated its RSA SSH host keys after vulnerability exposure. Attacker could impersonate GitHub's infrastructure in many of the middle attacks. So preventive action is migrated to ED25519 to ECDSA keys. So this was the preventive action, because when we have a particular key and when we move on from that key to another new one key, then this is the one of the best preventive action first instance. Demonstrated PKI key management is central to software supply chain security. So this was the very popular